Hello and welcome to Oplattery Videos, here to help you study, learn and succeed. Today's video is about something called the crossover rule. The crossover rule allows you to work out the formula of any ionic compound. But it does rely on you knowing the charge on the ions, the formula of any compound ions. So those are the things you actually need to know to be able to work this out. So how does the crossover rule work? Well, there are a couple of steps to it. First of all, you write down your name of the compound. Once you've got the name, you then put in the charges on the ions. You then would swap the values in those, but you don't swap the charges. And finally, from your swap values, you're able to then work out your formula. Okay. Easiest way to look at this is actually with an example. So I'm going to go for calcium chloride. So I've got calcium chloride. If a name ends in IDE, remember it's only that element in it. So it's chlorine within that. So calcium then, calcium group 2, it has a charge of +2. Chlorine is in group 7, has a charge of -1. So what we do is we swap over the values, but we leave the charge part where it is. So the 1 would go that way, the 2 would go that way. That then gives us a 1 and a 2. My formula then is Ca1. Imaginary, I don't need to write the 1, then chlorine, Cl2. There's my formula for calcium chloride. Okay, so we'll try another one, aluminium oxide. So oxide, that tells me only oxygen is present as the second part of this compound. So aluminium, group 3, charge of +3. Oxygen, group 6, charge of -2. So again, we swap over the values. 2 goes that way, 3 goes that way. That gives us 2 and 3. So I get Al2O3. Why is it this way round? Well, any ionic compound, you're looking for an overall charge of 0. So realistically, this is -2 times 3, which gives me -6. And on the other side, I've got +3 times 2, which also then equals +6. +6 minus 6, whole thing balances out to be overall 0. That's with standard ions. So if I have compound ions instead, so sodium sulfate. So I've got sodium and I've got sulfate. So sulfate is a compound ion, it's SO4 with a -2 charge. I know sodium group 1 +1, sulfate -2. So again, swap over my numbers, so that goes that way, that goes that way. I've got Na, there's my 2, sodium, the 1's gone that way, so Na2. Sulfate was SO4, there's only one of them, no requirements for brackets around that then. A little bit further on, let's try calcium nitrate. So calcium nitrate. Calcium, group 2 +2. Nitrate, NO3 and it's got a -1 charge. So again, swapping our numbers over, 1 goes that way, 2 goes that way. So I've got a 2 and a 1, so it becomes Ca, imaginary 1 again, and I need 2 lots of nitrate, so NO3, and there are 2 of them, so I put brackets around to show that the compound ion stays together, and there are 2 of those. Other unusual circumstances we can get if we have Roman numerals in there. So I have iron, Roman numerals 1, 2, 3, hydroxide. The 3 means that the ion has a +3 charge, so iron is +3. Hydroxide, OH, -1. So again, swap over our numbers. There goes the 1, there goes the 3. So 1 and 3. I'm going to need 3 hydroxides. It's a compound ion. I'm going to need a bracket around it. So it becomes FeOH3. So, crossover rule. What it allows you to do is work out the formula of any ionic compound. You start with your compound name, your charges on the ions, you swap over the values, and then from that you use it to write a formula. If you've got compound ions in there, you need to know their charges. You can see the compound ion sulfate, SO4 with a -2 charge. If there's more than one, as there was in calcium nitrate, I needed 2 of them, I put brackets round the nitrate to show that it's a compound ion and it's going to stay together. If I've got Roman numerals anywhere in my formula, iron 3 hydroxide, that tells me the iron is on a +3 charge. So there we go. Crossover rule to allow you to work out the formula of an ionic compound. Thank you for watching O-Plattery videos. I will see you again soon, and apologies for any extra noises as given by my little helper, my cat. Bye bye!